Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Sharon Florentine. Welcome to today's DevOps.com webinar, Stop Testing in the Dark, How Full Visibility and Codeless Shine a Light on and Fill Your Enterprise Testing Gaps, brought to you by digital.ai. We have an awesome webinar for you today, but before we get started, I need to go through some housekeeping items with you. As always, this presentation is being recorded, so if you miss any or all of it, you'll be able to go back and watch it again. We'll be sending an email with instructions for how to access the webinar on demand, or you can visit us at devops.com/webinars, and it will be there for you as well. We are also taking questions throughout the presentation, so you can use the Q&A tab on your webinar console to submit questions for our speakers today. All right, well, with that, I am pleased to introduce to you today Guy Ariely. He's the CTO of Continuous Testing at digital.ai, and Juan Lugo, the Product Marketing Manager at digital.ai. I'm going to turn my camera off and put myself on mute and let you gentlemen get right to it. Thanks, and take it away.
Thank you so much. All right. Hi, everyone, and welcome to, as she said, Stop Testing in the Dark, How Full Visibility and Codeless Can Help You Identify and Fix Your Enterprise Testing Gaps. So before we dive into kind of the main portion here, the Codeless, let's kind of discuss briefly, how software delivery has developed over the years and why it's become such, so many different buzzwords have came from this industry. Certain things are pertaining to testing, such as shift left, continuous testing, continuous automated testing, CI/CD, so on and so forth. So in the quote unquote age of the customer, customer experience is what makes or breaks organizations ultimately. And digital experience is at the forefront of the customer experience itself. And so web and mobile applications are expected to provide consistent customer experience across all channels at any time and everywhere in the globe you may be. And with that, dev teams are under vast amounts of pressure to constantly ship new web and mobile apps within shorter timeframes as time goes on, but also without compromising the quality of the applications themselves. And so as software delivery cycles have become shorter and shorter over time, several new methodologies have been coming to fruition just to kind of create efficiencies and effectiveness around these processes. Some of these include Agile, continuous integration, DevOps, and continuous delivery. Those are some of the most notable ones we've heard here in the industry. There is a common trend here with these new practices, and it's the thought of developing in small increments, committing code often, and fostering visibility and communication amongst all of the working groups, all designed to enable change and faster validation of software. Okay, so as y'all can imagine by now, the demand for faster product releases, optimal app performance, and ultimately happy customers, as I said, are the top priorities for companies that are looking to differentiate themselves in this rapidly changing, highly competitive market that we are in. And with that, we have IT leaders striving to adopt modern testing approaches such as continuous automated testing that can help companies not only keep pace with modern delivery, but also ensure that they are providing an optimal digital experience for that drives value for the business and for the customers. And ultimately, what it boils down to is that testing earlier, better, and faster are the new imperative for organizations. So increasing the release velocity and improving the customer experience, again, are the top priorities that are going to help these organizations differentiate themselves against the competition. The problem rises when testing occurs at the end of the software lifecycle. And this is typically where developers receive test results, and it's also when defects are significantly more time-consuming and difficult to fix, which can delay their time to market. It can drive up the cost exponentially and increase the business risk across their entire software release candidates. So what are the implications for organizations addressing bugs post-release? Well, the main overarching one is going to be financial setbacks. And then the ones that branch out from there are the brand damage, the customer retention, and in many cases, the regulatory compliance. And this is not only due to leakage, there's a data leakage of some sort as a consequence to the compliance issue. There's also other regulatory compliance factors that applications or developers have to consider, such as uptime in application and so on. And so we have companies increasingly taking the shift left approach to where testing starts earlier and happens continually throughout the delivery process, using automated approaches and codeless capabilities that provide ease of use for all testers. It enhances the visibility into test cycles and passive execution within the applications. And it provides actionable feedback in the form of analytics and reporting to create efficiencies within the test executions. And so with that, the testing strategy enables faster feedback loops so developers and testers can fix defects when they are easiest, they're fastest and cheapest to fix. Okay, so how exactly does this impact an organization's bottom line? What are the financial repercussions of not addressing bugs earlier in the software delivery process, but rather waiting until production, or even worse, addressing the bugs post-release? Well, as you see here, the bugs that are found in the earlier stages of the SDLC cost on average between $25 to $80 on average to fix. However, bugs that are found and addressed post-release or during production consequently cost organizations between $7,500 to $16,000 each to fix. So what we have here are a few relevant factors that can cause these issues. First off, we have the vast shift towards the work from home or remote teams, which has resulted in strained collaboration and communication, as well as an extended feedback loops across the entire SDLC or system development lifecycle, from R&D to testing and QA teams. So as an example, you can no longer take an update to somebody that works within the same organization as you in the same facility, run it to their desk and confirm a testing window for a tight deadline. This means essentially that organizations must figure out a way to adapt quickly to meet both the demand of their organization, but also to improve the old processes they have in place. QA and testing teams are faced with the challenge of balancing process execution and new initiatives as well. And as working groups adapt to changing environments, enterprises are focused on the business side of it. So the business continuity and accelerating new digital initiatives. And with that, manual testing is not effective for modern enterprises, piggybacking on the efficiencies, as the demand for continuous quality increases. And this is certainly have been the case in the last couple of years, and especially in the last 15 months. And so as you can imagine, delayed testing feedback results in significant setbacks as it pertains to product deployments. And this is due to the development teams not receiving the test results earlier, but rather later in the software development and delivery process. And with that, we have distributed teams that are faced with the delivery bottlenecks as they collaborate on testing while setting disjointed delivery timelines. All right, so let's go back in time, as it says. So what is code visualization? Well, because complex code is difficult to read and it makes code maintenance even more costly, code visualization emerged, and it aimed to bridge the gap between what you think your system looks like and what it actually looks like, to enable the users to understand what they're working with and to make it easier for them, for the organization and the all stakeholders to collaborate with confidence. All right, so here we have two representations of what code visualization looked like, or what it can look like still. You can see that it's intuitive, it's difficult to understand, and if you aren't the most technical tester, then you're not going to be capable really to leverage this tool without having some or oversight or having some help. So here we have a few reasons as to why it failed. For one, it did not reduce the complexity of the code. It introduced an alternative to conventional coding, but utilized the same complex logic. So as you saw in the visual, it doesn't really give suggestive code. It doesn't help the user kind of find their way if they're stuck in any portion of it. So it introduced an alternative essentially to conventional coding, but again, utilizing the same complex logic. And with complex logic, usually that results in complex visuals and presentations. Now, obviously, this didn't meet the requirements of the stakeholders because that's not what they had in mind when they deployed a code visualization tool. And in turn, it did not scale at the level that the enterprise required. So where do we go from here? Okay, so the question here is mainly like, where do we go from here? But really, we have to consider who are the stakeholders that are gonna that we should enable or are gonna be able to push this initiative forward. So first off, we have the dev testers, and these folks typically don't like testing. They like to automate. They would rather do so through programming in their own IDE or integrated development environment. This requires a no record, no replay. And if they want to ensure a smooth transition, two actionable items that they will need are first and foremost to learn automation principles and writing code that can be easily automated, as well as learning about QA methodologies. Then we have the technical tester who understands code but doesn't necessarily program. They use scripting languages fluently as well as scriptless, and record and play for automation. Oftentimes they have to decide the direction, whether they want to be a domain expert or automation engineer. And then finally, we have the business tester who has limited technical acumen for scripting, coding skills, so on and so forth. And as such, they prefer fully codeless tools for testing. Now, this group needs to focus on automation, and they need to focus on utilizing tools that are going to enable them to actually do the test execution. So that's going to be no code, low code, or codeless. So what is codeless and why is it important? So codeless software development is a form of a visual software environment that is used to design and manage software applications with minimal to no use of code or script. This enables software developers to quickly build applications utilizing an intuitive tool. And this form of development is appealing because, again, it creates ease of use for all the users, allowing them to focus on non-programmable testers to contribute to the app testing cycles and workflows. And it can be useful to both the developers and the business testers, again, only because it's greater for enterprise testing as far as expediting the release cycles that perhaps have backlog development teams and need to utilize business testers as developers themselves. And ultimately, we can break it down to three main benefits for organizations. It can optimize visibility through an intuitive yet comprehensive solution that enables testers to gain the insight into all paths of execution within applications. It enables testing to start earlier and continually throughout the delivery process by using the automated approaches, and thus allowing the more technical devs to focus on the more complex testing, right? And so overall, the testing strategy enables faster feedback loops through the visibility that's gained within the paths of execution and the test process itself. So that developers and business testers can actually fix the defects that are easiest, fastest, and cheapest to fix. So here we have the benefits to deploying a solution that leverages codeless and continuous automated testing. This enables the QA and R&D teams to eliminate inefficiencies due to the manual testing, leverage full visibility, again, while they're using their single testing solution across multiple environments and devices. And it enables rapid feedback across the QA and engineering teams so that they can ultimately release quality applications at a faster rate, focus on issues that impact the value creation for customers, accelerate the development through aligning QA and engineering efforts, and so that they can streamline the test cases and use real devices. Now let's discuss the benefits for technical and the non-technical testers. Codeless enables the technical testers to streamline their testing process and dedicate more time to further innovation or the more comprehensive testing. They don't need to spend their time doing extra QA or cleaning up preventative manual errors. And with that, it enables them to shift the less technical testing responsibilities to less technical testers. And in turn, this allows them to utilize the less technical testers as, or tests rather, as the baseline or the foundation for more comprehensive tests, because users can repurpose managed tests that have been executed, recorded, and saved for reporting and analytics. And as far as the less technical testers are concerned, they're enabled to execute test functions with greater ease and confidence, and leverage suggestive coding via Codeless, and continue utilizing those test executions to ultimately shorten the feedback loop. And by alleviating technical testers' workloads, they're able to, again, release projects into the market quicker. So model-based testing. So what is model-based testing? Simply put, it's a traditional or antiquated software testing technique that where tests and results are derived from models within the system being tested. This sounds fair enough, right? Well, the problem is that in these models, they're created manually, and so they are resource intensive, meaning that this code, this costs the coders or the organizations overall more time and more money to execute. However, by deploying an automated solution, enterprises are able then to mitigate all the constraints with time and the additional costs associated with this method. And in doing so, the teams can focus on executing more tests at a faster velocity with full visibility into all paths of execution within their applications. On the other hand, enterprises that leverage a comprehensive solution, such as that of digital.ai continuous testing, they're enabled to automate testing models to accelerate release, gain full visibility of all the changes occurring within their test cycles, save resources that would otherwise be spent on overhead and executing endless numbers of manual tests, and give technical users or testers the ability to automate simple tests and the flexibility that they need for the more complex test executions. Okay, so with that, I'm going to pass this on to Guy, and he's going to conduct the demo for us.
Great, thank you, Juan. Let me share my screen. Okay, hi everyone. I'm Guy. I'm a Digitalai continuous testing CTO, and I will try to show you a different approach or what we see as a real codeless. Juan already explained the difference between code visualization and codeless. And what we are doing, we are leveraging model-based testing in mobile application to generate a codeless environment that is much more simpler. And now, in order to show you that, what I'm going to do first is this is a mobile device that I'm going to use. I have a pool of 5 mobile devices that I'm going to use in this demo. And the first thing I'm going to do here is show you the application we're going to use. So this is a relatively simple demo banking application. It has, once it launched, it has a login screen. If I will click here on the login button, I will get this error dialog. I can enter a username and a password, and then I will be able to log in into the application itself. And then I can navigate within the application, move between different activity and operate different tasks within that application. So I can do different things within that application. Currently, I'm using the Android version. So I can obviously log out and return to the main screen. I'm going to release this device and let's go into the codeless solution itself. And what I'm going to, I want to start from scratch. So I'm going to create a new project or a new workspace, and I'm going to name it P22. This is my next in the list, and this is the application I've just showed you. This is the Airbank application. I'm going to select it and create this project. And the first thing we are going to see here is something that is called an exploration. And an exploration is a concept where we can explore the application under test. So I can leverage the fleet of devices and the AI bot capability to really quickly map the application under test and create a model. So I'm going to utilize 3 devices out of my pool and just start the exploration. It's a very simple process. What will happen now is, out of my pool of devices, we're going to select 3 devices, and those devices, first of all, the application is going to be installed and launched onto those devices. And then what you will see is that the bot will start to explore the application, trying to click on a different element and trying to perform a different operation in order to build a model around the application under test. And this is the important part here, creating this model. So let's look at the devices. So we can see here that 3 devices were utilized. And if I will go to the execution, I will be able to see that the application will be installed on all of those devices. The application will be launched, and you will start seeing a different operation happening on the mobile application. So here we can see everything is happen, or the exploration process happened on the 3 devices. We talked about a model, and I want to show you what this model is all about. And here I'm going to show you the models. And this is what we currently know on the application. We know that if you will launch the application, you will get into the login screen. And we know that if you will just click on the login button, you will get this error dialog. And if I will refresh my model, what you can see is that now we also know that if we will click on close, we will be back at the same screen. So this is what we currently know on the application. And what you can see is that this model was generated automatically. So I didn't need to do anything. You will also notice that the exploration ends. This engine understand is that there is nothing to do in this application at this point. So we slightly understand what is an exploration. An additional concept that we need to understand is gates. And what you can see is that the system identify a gate, and this is the login activity gate. And what a gate is a call for help from the user. So what the AI engine wants is some help from us to unlock this gate. And what you can see is that it identified this screen as a gate, and it needs my help in order to log in, to provide the username and password. And there are a few ways that I can log in. I can provide an Appium code, or there is a very simple format that we can use. And the solution here is also creating this format for me. So it will add the username, password, and login. And the only thing I need to do is provide the username here and the password here, and I'm good to go. What I'm going to do in addition, I'm going to parameterize this. So I'm going to use a syntax here saying that this is the user, and I'm going to use a company as a default, and this is the password. So now I will be able to change it as I'm executing a new set of tests. Okay, so I've saved this gate, and now this gate got unlocked. What we can do now is continue our exploration. We will use 3 devices. You can see the parameters. So if I want, I can change them. I'm not going to change them. And I'm going to start the new exploration. So the exploration will start from the point it ended. Here, if you remember, this is where the exploration ends. What you will be able to see now is that the process will continue from the point we left it. 3 devices will be selected, then the application will get installed, it will get launched, and then we will see that we will start logging into the application based on the gate that we provide, and this model is going to be extended. Let's take a look at the actual devices. So we can see that the devices are being allocated, and soon enough we will see that the application is being installed and everything. If we will have multiple devices, then we will be able to utilize more AI bots, and this process will run faster. So as many devices as we will have, the exploration process will happen and will run faster. Here you can see that we are now logged into the application. So we have passed the login gate, and you will see that now all of the bots are actively working on the application, performing different tasks within the application. So here we are clicking on the first button, for example, and probably here we'll explore other parts. Let's see how the model looks like now. So now it's starting to be interesting. You can see that the bot is able to learn and go deep dive into the application, identifying all the screen and all the connections between different screen. And as I will refresh this view, you will see that more and more tasks are being generated and everything is running in parallel, and we can see that we are exploring and identifying and expanding the boundaries of our understanding of the application. I don't want to wait too much. It will take probably a few more minutes in order for the entire model to be explored. Here you can see what we have so far. So let's continue from this point, assuming that we have explored the entire application. What we are going to do now is, based on the current model, we are going to generate tests. And what you can see here is that it says, okay, we can generate 12 tests. Let's go and generate those tests. And I'm going to move into the test tab, and let's try to understand how those tests are getting generated and what they are doing. So by the name of the test, you can see that the first test will navigate to the login screen, will click on the login button, and will verify that we are in the error dialog. You can see that we really generate 14 tests, and this is incredible, because without any coding capabilities, with minimal amount of work, we generate those tests. And if we will go to the edit part, we can see all of the steps that we are performing. Navigate to the login screen, click on the login button, and verifying that we got this error dialog. Now I can add my own verification and perform additional validation and duplicate this test, so we can do many other actions. And we can go into other parts here and see what the other test, and what you will see is that we were able to really simplify the test because we are using the model. When we say navigate, we don't say how to log in, what username or password to use. It will be done based on the latest model. So if you remember, this is the current model that we have. As we speak, you can see that it is getting bigger and bigger. And even now, if I will generate tests, you can see that it's fine additional 10 more tests based on the exploration that is currently running in the background. So we were able to generate those tests very rapidly. We can obviously select all those tests and execute them. We can parameterize them, change the version we want to execute on, and so on. Usually, I don't want to do it now because I'm not sure we have enough time for the test execution. What you need to understand is every time you will have a new version of the application, even with the slight change, you will run a new exploration. And the tests that you generate will continue to be valid because they are not based on a highly strict heuristic. As you can see, each test here is starting with navigating to a screen. It never says how to navigate to the screen. So if in the future anything changed, the login screen, it will not require any change in the application itself. Everything here will continue to be valid. So this is very important in the life cycle that you are trying to create when it's come to codeless and continuous testing. The capability to get an application in a matter of minutes, generate dozens of tests, execute those tests is a very important capability. You can see that we have identified 2 new gates, and we can continue in the process of unlocking those gates in order to expand into new boundaries in the application. With that, let's end the demo and continue with the presentation.
Hey, Guy, can I ask you a question about the all the paths you showed there? So, what kind of benefits are there for the users with this level of visibility?
Well, can you repeat the question?
I was just saying, with this level of visibility, how is this beneficial for the users? Like, I'm assuming there's tons of benefits for users that are gaining that kind of insight, not only into the application, but also what's happening behind the scenes with all the test results.
Right. So what you don't see here, because we have just one version and we just started to work on this application, is the insight that we can provide based on a new version of your application. And I will show it in one of my slides where we can show insight on on failures on a specific version, on a specific screen size, so we can nail down issues to a very specific problem, and we can reduce the investigation time by huge amount of, so we can reduce this those effort dramatically. So as you can see here, the exploration here ended, and we have a full model of this application, and now we are good to generate all of the tests. And this is, from my perspective, it's amazing, because we were able to work for a few minutes and generate something close to 50 fully valid tests based on this just introduced mobile application.
Right. So just as it says here, in other words, you're able to automate your testing models to accelerate the releases of your product, right?
Yes, absolutely.
Right. And in doing so, you mitigate all the bottlenecks that organizations experience when they're using more traditional solutions, if you may, such as executing endless numbers of the manual tests and so on, right?
So if you would take a typical application similar to what I've shared here and try to automate, or give it to your automation team and let them go and start automating it, it will take between a few days to a few weeks, maybe months, to come up with around 50 tests that cover the entire application. And this is something that we were able to do in a few minutes without all the technical knowledge, without knowing Java or anything around that. Now, and this was built specifically for the continuous testing, to be able to adjust the changes very, very quickly and provide feedback to the developer in a matter of minutes and not weeks or months.
Right. Mm-hmm.
So here we can see some additional use cases where we provide insight on the application user experience score. We can know whether your application user experience improved or declined between version. We can provide you insight on performance or UI anomalies within the application. So we can say, login transaction performance reduced in 20%, or you have a problem on iOS 14.1 on a specific version. It looked like a certain part of your application or your functionality doesn't work very well on that version. So when you get the issues, they are really narrowed down to the actual problem that you need to fix, and this is super important. Something I didn't show and also available is our capability to generate Appium Test based on the test that you have seen here. So if you don't want to use you want to use Appium, we can just convert those tests into Appium, and then you can run those Appium tests, and you can use the model to navigate within your application. So there are a lot of useful use cases that are based on having this model.
So what you're saying is that they're able to leverage the open source tool Appium and then be able to have some interoperability between the digital.ai solution and that tool itself, right?
Yes, absolutely. So personally, I think that using the code itself introduces a lot of benefits, because when you export the test into Java or any other language, you disengage from the model itself. But this option is valid, and in some cases it's very useful. I think that using an API to leverage the test and execute them continuously, this is the right approach. And we provide an integration into Jenkins, and it enables you to build a continuous testing solution in a matter of minutes and not weeks or months.
Gotcha. Okay.
Let's go to the next slide. Yeah, here you can see how you can plan an execution and select the version to execute on, build the full matrix of version, screen size, manufacturer, operating system version, and so on. We are able to identify application crashes and really generate smoke tests very efficiently.
So do you have access to like all the newer operating system versions? Like, for instance, I know the iOS 15 was released not so long ago. It must have been like a week ago for emulators. Do you guys have access to that?
Yes. So first of all, if you are following Digitalai continuous testing on the different channel, you will see that we are already supporting iOS 15 from something like 48 hours after it was the first beta was introduced. So we have an R&D team that expect this version and work around the clock, because it's very important for our customer to do those testing as early as possible. And we are already supporting iOS 15, and we have customers that are already testing it against the newest versions.
Right.
Yeah, I think we already covered the exploration, building the model, identifying the gate, and then generating tests based on the model and then executing those tests. So if you remember, this is the workflow that we introduce. The fact that you don't need to generate this model manually, and you can leverage the computing power of your mobile lab, as well as different AI heuristics. This is the breakthrough. So we do believe that it is changing the way functional and client-side performance is done.
Right. So I believe this ties into the digital.ai approach, which entails leveraging AI along with shift left and codeless and the optimal visibility, as we've been saying, in order to create a truly intelligent platform that connects all these software development and delivery efforts to business outcomes ultimately. This platform connects agile planning, software delivery, application security, and quality so that you can meet the increased market demands. And the goal here ultimately is to continue to provide business context throughout the entire value stream delivery. So with that, let's go ahead and open up the floor to questions. I believe we have a couple here.
Sure do. Thank you both so much. That was awesome. All right.
Thank you.
Yeah, you're welcome. So first one here, Guy used a pretty simple application for the demo. How does this enable technical testers to execute more complex tests?
Yeah, so I didn't fully demo the codeless part where you can record and add your own step and use a snippet from Appium. So we do have all of those options, and you can automate a much more complex scenario. In the sake of the demo time, we selected a simple application, but we have some of our customer that has a very complex application, financial or from other areas that are using these techniques.
Right. So essentially, it sounds like the main point here is that regardless if you're using every bank as we use for the demo, or if you're using a more comprehensive application that has, you know, all sorts of different factors to consider, whether, like Guy said, if it's in the financial sector, if it's in the medical, you're going to have so many compliances that you have to adhere to. So that's obviously, you know, something that we keep in mind and that we think about when we're doing these demonstrations. So the main takeaway is that while you are focusing or enabling your technical testers to focus on the more comprehensive and more difficult, complex tests, you're enabling at the same time your less technical testers, your business testers, if you may, to focus on the less comprehensive tests, and you enable them to automate that process. And in turn, what that's going to do, it's going to make the life of the technical tester a lot easier, so they can focus on the more innovative or comprehensive tests. And so ultimately, what does that do to the business? It enables you to shorten your time to market and the release cycles, right? And the feedback loop as well.
Yeah. Okay. What is the difference between emulators and real devices, and which one were you demonstrating there?
So I think that there is a big difference between emulators and real devices. It's really operating system dependent. So in Android, there is a technology that enables the APK to run on different technologies, but the CPU that obviously you're using an emulator for is x64, and when you run on mobile devices, it's an ARM, and this is a huge difference, especially if you have some native code in your application. So it will be wise to test on real physical devices. What we demonstrated here are physical devices. So all of we have used a pool of 5 devices. All of them are real physical devices that are located in our US data center. We have around 8 to 9 data centers around the globe. We have 2 in the US, we have 1 in Canada, we have 1 in the UK, Germany, in the Middle East, in India, Singapore, and Australia. So you can get devices in all of those locations.
And it's extremely important, as Guy said earlier, utilizing real devices, making sure you have access to the geographic implications of testing in certain regions. So going back to the compliances, you have CCPA in California, you have GDPR overseas, and there's so many of them. You have to adhere to all those compliances, and at the same time, you have to keep in mind from the user perspective, how is this going to affect the performance of the application, the user experience? When I'm utilizing this application, is there a lag time due to the security measures that you have to put in place to adhere to the compliances? But then on the other hand as well, you got to make sure that you're utilizing emulators as well. And you got to make sure you have access to them really early on, as soon as they're released. As Guy mentioned, digital.ai already has access to the iOS 15 version, which is in beta. And that is enabling our customers in turn to test on this operating system. So they are ahead of the curve. And once that new version is fully released to the public, then they're able to make sure that they're adhering to the compliances again. There's no gaps as far as security or the compliances overall or performance.
Okay. All right. I think we've got time for one more. Let's see. How do you calculate the UX score in the bot solution?
Sure. So the advantage of having a model is that we know everything about the application. What you need to do as a user is you need to map the different operation and to say this operation is more important than this operation. Then we can calculate the user experience for each operation. We take into factor the amount of clicks and typing you need to do. We take into factor the size of the elements that you click on, the contrast of the element, the performance of the application, how quick it responds, and we generate an holistic score based on all of the activities. So sometimes you will make changes to your application and you will improve the user experience for one task, but then you will create a bad experience for other tasks. And it's all about balancing between the task based on what is important in your application.
Gotcha. Yeah, you don't want to fix one thing and then it cascades and creates a ripple effect of yeah. All right, great. Well, I think that's about all the time we have for questions. Folks in the audience, if you submitted a question and we did not get time to answer it, please rest assured we're going to take all of the questions and send them over to Juan and Guy, and they will be able to answer those offline for you. So thank you so much again for attending. As a reminder, this session has been recorded, so if you missed any or all of it, you'll be able to go back and watch it again. We'll be sending an email with instructions for accessing the webinar on demand, or you can always visit us at www.devops.com/webinars, and it will be there for you as well. All right, again, thank you so much for spending your time with us today. Thanks to Juan and Guy for this amazing presentation and demo, and we hope to see you again soon at another DevOps.com webinar. I'm Sharon Florentine, signing off.
Thank you.